In February of 1966, Jørn Utzon walked out of the most important project of his life. The concrete sails of the Sydney Opera House were rising above the harbor, but the interiors were still unresolved, the cost was climbing, and the building was years from completion. Utzon left Australia soon afterward and never returned. Yet the structure he abandoned would become one of the most recognizable buildings on Earth. Stick around, because the story of the Sydney Opera House is not simply about an architect with a beautiful idea. It is about a design that could not initially be built, an engineering team that had to invent new methods to make it possible, and a political conflict that separated a masterpiece from the man who created it. The building stands on Bennelong Point, a narrow promontory between Sydney Cove and Farm Cove. Long before the modern city existed, the land was a gathering place for the Gadigal people of the Eora Nation. Its English name recalls Woollaraware Bennelong, an Aboriginal man who became an intermediary between the local population and the first British colonists. A small house built for him once stood near the point. It was later replaced by Fort Macquarie, and then by a tram depot whose long sheds occupied one of the finest positions in Sydney Harbour. By the late 1940s, that location had attracted the attention of Eugene Goossens, the conductor of the Sydney Symphony Orchestra and director of the New South Wales State Conservatorium of Music. Sydney had grown into Australia's leading city, but its orchestra still performed in the town hall, a venue never designed to serve as a modern home for symphonic music, opera, ballet, and theatre. Goossens argued that a city with global ambitions needed a cultural institution worthy of its harbour. He also insisted that it should stand on Bennelong Point, where architecture, water, and skyline could become part of the same experience. The idea gained its decisive political supporter in Joseph Cahill, the Premier of New South Wales. Cahill saw the proposed opera house as more than a venue for wealthy audiences. He believed it could demonstrate that Australia was becoming a confident, modern nation with cultural ambitions equal to its economic growth. Bennelong Point was selected as the site in 1955, and on February 15, 1956, Cahill officially announced an international competition. The brief called for two main halls, one for concerts and large productions, and another for drama and smaller performances. The prize attracted more than 223 submissions from 28 countries. The winning submission came from a Danish architect who was still little known outside Scandinavia. Jørn Utzon's drawings were remarkably simple. They showed two groups of pale, curved roofs rising from a monumental platform and facing the harbour. The forms appeared to float between architecture and nature. People would later compare them to sails, shells, bird wings, or waves, although Utzon drew inspiration from many natural shapes and never reduced the idea to a single image. What made the proposal unforgettable also made it dangerously incomplete. The competition drawings communicated a vision, not a finished construction system. The roof forms had no clearly defined geometry, and no one yet knew how to calculate, manufacture, or support them. The jury nevertheless recognized their potential. The Finnish-American architect Eero Saarinen strongly supported Utzon's entry, and in January of 1957 it was declared the winner. Australia had selected an image capable of transforming Sydney. It had not yet selected a building that engineers knew how to erect. Utzon turned to Ove Arup, one of the most innovative structural engineers of the period. Arup had built his reputation by combining engineering discipline with unusual architectural ideas, but even his team found the opera house roof extraordinarily difficult. The designers explored parabolic forms, ellipsoids, and other geometries. Every option created a similar problem. Each roof would require different formwork, different calculations, and large numbers of unique concrete pieces. A shape that looked effortless on paper threatened to become impossibly expensive in reality. Before that problem had been solved, the government ordered construction to begin. Political leaders feared that delay might weaken public support or threaten the financing of the project. The tram depot was demolished, and work started in March of 1959. Civil and Civic began building the Great Podium, while Utzon and Arup were still redesigning the roof above it. The opening was planned for Australia Day in 1963, and the original estimate was roughly 7 million Australian dollars. Starting early created the appearance of progress, but it transferred unresolved design questions directly onto the building site. Bad weather, drainage problems, changing documents, and incomplete drawings pushed the podium almost a year behind schedule. More seriously, some of its columns had been designed before the final roof loads were understood. They proved inadequate and had to be reconstructed. Sydney was already pouring concrete beneath a roof whose geometry did not yet exist. For several years, Utzon, Arup, Ronald Jenkins and their teams moved through one roof system after another. They needed a form that preserved the drama of the original sketches while allowing repeated components to be manufactured economically. The breakthrough finally came from Utzon. Derive every shell from the surface of a single sphere. The idea grew from years of collaboration with Arup's engineers, but it was Utzon's solution that unified the entire roof. Imagine slicing differently sized pieces from the surface of the same orange. Every piece may have a different outline, but all share the same curvature. That common curvature changed everything. Instead of producing unique molds for every part of every roof, the builders could cast families of standardized concrete segments. Ribs of different lengths could be assembled from related pieces and arranged into the fan-like forms visible today. The solution did not simplify the appearance of the building. It simplified the hidden logic behind it, turning an expressive drawing into a system that a factory could reproduce. Even with the spherical solution, the forces inside the roofs were too complex for conventional hand calculations alone. The Opera House became one of the earliest major buildings to use digital computers extensively in structural analysis. These machines were primitive by modern standards, but they allowed engineers to test loads, stresses, and geometric relationships across thousands of calculations. Physical models were also tested in wind tunnels to understand how severe winds would press and pull against the unusual surfaces. Computers returned during construction. As each rib segment was positioned, surveyors measured its exact location. The figures could then be processed so that the team knew whether the structure was drifting away from the intended geometry. Small corrections were made before the next pieces were installed. At a time when most buildings were still designed and checked almost entirely by hand, the Opera House created a daily loop between the construction site, precise surveying, and digital calculation. The Australian contractor M.R. Hornibrook turned the site into something resembling a manufacturing plant. Thousands of concrete components were cast nearby instead of being formed individually high above the podium. An adjustable steel erection arch temporarily supported the ribs while they were assembled. This system, developed under Hornibrook engineer Joe Bertoni, could be altered for roofs of different sizes and then moved to the next position. Long before prefabrication and integrated digital construction became common industry language, Sydney was using both to build shapes that traditional methods could barely handle. The roof surface demanded another specially developed product. Utzon wanted it to appear brilliant in direct sunlight without becoming a flat, glaring white mass. The Swedish company Höganäs spent years developing what became known as the Sydney tile. More than 1 million small tiles combining glossy white with matte cream were arranged in a subtle chevron pattern. From across the harbor, the roofs seem uniformly pale. Up close, the changing finishes break the light and give the surfaces their texture. Innovation extended beyond the shells. The great end walls required large areas of laminated safety glass, used at a scale that was highly unusual for architecture at the time. Epoxy resin helped connect precast components. The mechanical system used harbor water as part of its cooling process. Architects, engineers, manufacturers, and contractors had to work together from an early stage because no profession could solve the project independently. That collaboration anticipated the integrated design methods now used on many complex buildings. By the mid-1960s, engineers had finally solved the problem of how to build Utzon's roof. The harder problem was now the relationship between Utzon and the people paying for it. Joseph Cahill had died in 1959, removing the project's strongest champion. Costs rose as the design developed, deadlines repeatedly moved, and public criticism intensified. After an election in 1965, the new government of Robert Askin placed the project under the authority of Public Works Minister Davis Hughes, a determined critic of its management. The dispute was not simply about artistic taste. Utzon wanted design information, specialist contracts, and communication with suppliers to remain coordinated through his office. The government demanded tighter financial control, competitive tenders, and direct reporting from architects, engineers, and contractors. Officials regarded Utzon's continuing design development as evidence that the project lacked discipline. Utzon believed their demands would destroy the unity and quality of the building. The conflict became personal and financially destructive. Payments to Utzon were withheld while the government demanded further documentation. By early 1966, his office was owed enough money that he struggled to pay his staff. On February the 28th, he met Hughes and threatened to leave. Hughes refused to release the money. Hours later, Utzon formally wrote that the government's actions had forced him off the project, and Hughes treated the letter as his resignation. Whether Utzon freely walked away or was deliberately pushed out would remain part of the controversy. Architects and students protested and called for Utzon to be restored. The government later offered him a reduced position under a panel of other architects, but he refused. He left Australia with his family and never returned. By then, the exterior concept was established and the shells were advancing, but many crucial interior decisions remained unfinished. The project now faced a painful question. Who could complete another architect's masterpiece without either imitating him or erasing him? Peter Hall initially declined the assignment himself. He had supported calls for Utzon's return and understood that taking the job could damage his own reputation. After the government approached him again and he spoke with Utzon by telephone, Hall accepted. He inherited a building that still needed to function as a working performing arts center. Seating, acoustics, stage machinery, circulation, glass walls, dressing rooms, and service spaces all had to fit beneath shells whose external geometry could no longer be changed. Hall and his colleagues, Lionel Todd and David Littlemore, discovered that trying to make the major hall serve both grand opera and symphonic music forced two very different sets of requirements into the same room. Opera needed a stage tower, scenery movement, and an orchestra pit, while concerts demanded a different arrangement and different acoustic conditions. The team ultimately made the larger room a dedicated concert hall and placed opera and ballet in the smaller theater. Interiors and plywood systems envisioned by Utzon were discarded or redesigned, while already planned stage equipment was removed. These decisions allowed the building to open, but they created compromises that lasted for decades. The opera theater had restricted backstage space and a cramped orchestra pit. In the concert hall, the great volume above the stage made it difficult for musicians to hear early sound reflections. Suspended acoustic rings were added in an effort to improve the problem. The exterior became universally celebrated, while performers and technicians understood that the beauty of the shells had imposed a difficult internal geometry. Construction continued through labor disputes, design changes, and relentless public scrutiny. The project originally expected to open in 1963 for about $7 million. It was completed roughly 10 years later for about $102 million. Much of the cost was financed through a state lottery, spreading the burden across years of ticket sales rather than relying only on ordinary government revenue. By almost any conventional measure of scheduling and budget control, the project had failed spectacularly. Yet, on October the 20th, 1973, those numbers temporarily gave way to the building itself. Queen Elizabeth II formally opened the Sydney Opera House before a vast crowd. Fireworks crossed the harbour, and Beethoven's Ninth Symphony formed part of the celebration. Utzon had been invited but chose not to attend, avoiding a return that might have reopened the political dispute. His name was acknowledged by Premier Askin, but the architect watched the building's rise to fame from the other side of the world. The public judgment changed with remarkable speed. What had been attacked as an expensive white elephant became the defining image of Sydney and, eventually, of Australia. The Opera House demonstrated that the country could produce not merely a useful cultural building, but an architectural work that altered the international perception of an entire continent. Its methods also traveled. Computer-assisted structural analysis, precision surveying, standardized precasting, large laminated glass walls, and close collaboration between designers and builders became increasingly important to later generations of complex architecture. Recognition of Utzon took longer. In the late 1990s, the Sydney Opera House Trust restored contact with him and appointed him as a design consultant. Working from Denmark and with the involvement of his son Jørn, Utzon established principles for future changes to the building. The former reception hall was rebuilt according to his ideas and reopened as the Utzon Room, the first interior space to fully carry his design language. It was a reconciliation, but an incomplete one. Utzon died in 2008 without ever returning to stand inside the finished opera house. The building itself continued to evolve. Stages, foyers, access systems, and performance spaces were upgraded, while major work in the concert hall addressed machinery, safety, and the acoustic weaknesses inherited from the original compromises. In 2007, UNESCO placed the Sydney Opera House on the World Heritage List, recognizing it as a masterpiece of 20th century architecture. It remains a working complex rather than a frozen monument, hosting opera, theater, dance, orchestral music, public ceremonies, outdoor performances, and events projected across its famous roofs. The Sydney Opera House is often described as the vision of one genius, and without Jørn Utzon it would not exist. But the finished building also carries the work of Ove Arup and his engineers, Hornibrook's contractors, Joe Bertoni's construction ingenuity, Peter Hall's difficult interior decisions, thousands of workers, and a government that both made the project possible and drove its architect away. Its history resists a simple verdict. It was a triumph of design and engineering, a disaster of administration, and a cultural investment whose eventual value exceeded every early calculation. So was the Sydney Opera House worth the delays, the enormous cost, and the loss of the architect who imagined it? Or does its beauty make us too willing to forgive the failures that almost destroyed the project? Share your view in the comments, and if this story changed the way you see those famous white sails, support the channel with a like, subscribe for more documentaries about the world's greatest engineering achievements, and turn on notifications so you do not miss the next story hidden inside a landmark.